In this video, I'm going to discuss about design of 4-bit multiplier using verilog hardware description language. So this the program is based on the structural modeling. So I'm going to use Xilinx Vivado software. That is 2017.1 version, and the FPGA used here is Basis 3 board. So first, let me explain what is a multiplier. So for that one, let me take my circuit diagram. So this is my circuit diagram. Okay. Let me take one example. Suppose I am going to multiply y3, y2, y1 and y0 with x3, x2, x1 and x0. So let me take that value of y as 4 ones and y3, y2, y1 as 1 0 1 0. So how to multiply this one? So if I want to multiply, first I have to multiply 0 with 4 ones. So if I multiply 0 with 4 ones, I will get 0 0 0. If I multiply 1 with 4 ones, I will get 1 1 1 1. And similarly I will get 0 0 0 0. Next 1 1 1 1. So after that I need to add this one. So if I add, I will get 1 0 0 1 0 1 1 0 as my answer. So if I add 1 1, I will get, if I add 1 1, I will get 1 0. Okay, so if I add triple 1, I will get 1 1 as. Okay, so this is the answer. So let me, so for doing this one, I'm plotting this picture. Okay, so here I'm using 3 4-bit adder. Okay, so here I've given the y1 value. So y1 value here is 1. Okay, so y2 is 0 and y3 is 1. So if I multiply y3, y1, y2 and y3, y2, y1 values 1. So if I multiply using this indicate, I will get 1 1 1, right? Similarly, this is 1 1 1. So if I multiply with 0, I will get 0 0 0. So this is 1 1 1. So if I multiply with 1, I will get 1 1 1. Similarly, you can see this is 1 1 1 1. So what is x naught? X naught value is 0. So if I multiply with 0, I will get 0 0 0. Okay. And z value is 0. Okay. So this 0 is given to P naught. So P naught value is 0 now. Okay, so what is the function of the 4-bit adder? So the 4-bit adder adds the 4-bit with another 4-bit. Okay, so here this is my first 4-bit and that has to be added with this 4. So 4 1 is added with 4 zeros. So you will get, if I add 4 1 with 4 zeros, I will get answer as 1 1 1 1 and carry as 0. Okay, so I have to substitute 1 1 1 1 and carry as 0. Okay, so this 1 is going to P1. So P1 value is 1 now. Okay, so again I'm going to add this 4 zeros with 0. So I'm going to add 4 zeros with 0 1 1 1. So if I add, I will get 0 1 1 1 and carry is 0. Okay, so 0 0 1 1 1. So P2 value is 1. So I'm going to add 4 ones with 0 0. So I'm going to add 4 ones with 0 0 1 1. So if I add, I will get 0 1 0 0 1. So answer is 1 0 0 1 0. Okay, so you can see answer is 1 0 0 1 0 1 1 0. This is my answer. So I have explained you how to draw this diagram for the 4-bit multiplier. So from this one, I can see what are the components I have used. I have used nearly 4 4, 8, 12, 16 AND gates, right? 16 AND gates and 3 4-bit adder, right? So that's it. Okay. So let me start with the full adder program. So you know the full adder, how to write the full adder program for the using verilog, right? So you have to start with the module name is FA. So you have 2 inputs and 2 outputs and 3 inputs. Okay. So outputs are sum and carry, and inputs are A, B and C. Okay. So it has to be closed and given semicolon. Sorry. So this program I have written using data flow modeling. So you have to assign sum is equal to A XOR B XOR C. So this is a symbol for the sum, and carry is AB plus BC plus CA. Okay. So this is about full adder. So from the full adder you have to draw the 4-bit adder. Okay. So the diagram is in order to draw the 4-bit adder, this is so this F0 is nothing but our full adder, and so you have totally 4 full adders. So in order to draw the 4-bit adder, you have not to write the program for the 4-bit adder. With the help of this diagram only, you have to write the program for the 4-bit adder. Okay. So you can see how many inputs are there. 9 inputs are there, and 5 outputs are there, right? That is 4 sum and 1 carry. And I have used this F0, F1, F2, F3 are my full adder. Okay. So let's see how to write the program for the 4-bit adder. Okay. So you have to start with module. Okay, module, and I have used MUL as name for the 4-bit adder. So how many outputs are there? The totally 5 outputs are there. That is S0, S1, S2, S3 and carry. And how many inputs are there? Nearly 9 inputs are there. So I have assigned it as A0, A1, A2, A3 and B0, B1, B2, B3, and C is my input. Okay. So in that, if you see how many wires are there, wire is nothing but interconnections. So if you see, the picture, so these are my inputs, right? These are my outputs. So in between these 3 points are called as wire. That is interconnection. Okay. So these are my wires. Okay. So for that one I have used C. Okay, C0, C1, C2, C0, C1 and C2. So if I write the program for the full adder, so I have to take FA. What is FA? FA is a name of the full adder. So I have used for previously, you can see for full adder I have given the name as FA. Okay. So FA is my FA, and you can see I have written sum, carry and ABC, right? So I have to write it like this only. Okay. So FA is a full adder and it's the name. So sum is S0, carry is C of 0. C of 0 is wire here, right? And then followed by A0, B0 and C. Likewise S1, C1, A1, B1 and C0. S2, C2, A2, B2 and CF. For the fourth full adder, C3, S3, CAR. CAR is my carry. Carry out this one. Okay. So carry, and then followed by A3, B3 and C2. So this is about 4-bit adder. So next I am going to write the program for multiplier. Okay. So So I have to start with module, and multiplier is the name of the circuit, and you see I have output as P0 to P7. So I have written like this: 7 is 0 of P, and input is x0 to x3, and y is y0 to y3, and C is my input, and input Z. So input Z is nothing but here. This is input Z. Okay. So totally, how many interconnections are there? You can see. These are all my interconnections: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Yeah. So M0, M1, M2, M3, M4, M5, M6, M7, M8, M9, M10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So it starts from 0 to 22. So these are my interconnections. So let me write 16 AND gates are there. So AND, if I use AND, it will perform the operations as AND. Okay, so AND is a keyword. So AND, name of the AND gate, followed by output, comma, inputs. So if I perform x0 and y0, I will get the answer as, if I perform x0 and y0, I will get the answer as p0. Okay. Similarly, if I perform x0 and y0, I will get the answer as m0. Okay. Similarly, if I perform x0 with y2, I will get m1. Likewise, if I perform x2 with y3, I will get m10. Okay. So this is how I have written the AND gate program. Okay. So for 16 AND gates, I have used this formula only. So, and I have used nearly 3 4-bit adder, right? So these are my 4-bit adder, and the name of the 4-bit adder is H1, H2, and H3. On that, in the 4-bit adder, it has to start from M14. What is M14? So here, M14 is a carry. Okay, carry followed by the sum. Okay, M13, M12, M11, and P1. Okay, so it has start from M14 followed by P1, M11, M12, M13. P1, M11, M12, and M13. Okay, it has to start from the LSB of sum to MSB of sum. Okay, next M0 to M3 and M4 to CM. So where is my M0? So M0 to M0 to M0, M1, M0, M1, M2 and Z, right? M0, M1, M2 and Z. Then M3, M4, M5, M6. M3, M4, M5, M6 and Cn. Okay, Cn is here. Okay, so similarly for this 4-bit adder, you have to start from M19, P2, M22, 21, 20. Then it has to start from here, right? M11, M12, M13, M14, M7, 8, 9, 10. Then Cn. Okay. So you can see M19, P2, M3, M22, 21, 20, 11, 12, 13, 14, 7, 8, 9, 10 and C. So similarly for the next 4-bit adder, you have to write like this. So after that, you have to complete the program with the end module. And you have to implement this using the constraint file and follow the procedure. You can implement this using this 4-bit basis board. We'll get the output, right? So this video objective is how to write a program for 4-bit adder using a structural mode.